In this video, we will implement a RAG API using FastAPI. FastAPI is a modern high-performance web framework used to build APIs, especially popular in AI, ML, backend services, and microservices. In today's video, we will create a simple RAG and serve it as an API for mobile or web application. So basically, we can use this API for a mobile chat application. So here we can upload our PDFs in the RAG application, and using these API endpoints we can ask questions about the PDF data. So let me show the demo first. First I am uploading a set of PDFs in this directory. These PDFs contains a sample content about a software company. I created this content for testing purpose. These are dummy content. Each PDF contains information about different category like holiday list, perks, insurance policy, salary and allowance, etc. So each PDF comes under different category. Each PDFs need to be uploaded in different directory. So the idea of uploading in different categories is it will be easy to make separate vector index for each category, and we can ask questions based on this category. So if you are uploading different kind of data, let's say hotel industry, it has different categories like room management, food and beverage, customer experience, pricing and office, operation, etc. So if you are uploading these kind of data, you can upload PDFs in this category. So categories may differ based on your data. So once we upload the PDFs, run this command to create vector data. Next we need to run this command to run the application. Now the app is up and running. You can use the endpoint /ask to get answers. If you run localhost 8000 tags, it will print all the available tags, which is basically the categories. Now using the endpoint ask, we can get answers from the model. In this post method, I am passing tag and the question. Now you can see the result from the model. So you can use this API for mobile and web application for building the chat application so that the user can ask questions based on your data. Now we can go through the architecture and check how it works. First, the PDFs or the data needs to be converted to vector data. For that, we use this model for embedding. This model converts the data into vector format and save in the vector database. Here we use files as the vector database. When a user asks a question using the ask endpoint, it converts user query into vector embedding and search in the files database and retrieve the top chunks. Then it creates a prompt using these chunks and pass to the LLM. The LLM generates the output and returns the result. This LLM is running in Ollama platform. So that is the workflow of this application. Now we can check the installation and setup. First of all, you have to install Ollama in your system. Ollama is a local AI model runtime that lets you download and run and manage large language models directly on your computer. So you have to install Ollama. Next step is to pull the models. Here I am using DeepSeek. Use this command to pull the model. You can use other models like Mistral, Llama, etc. Once you're done with installing the models, next step is to set up the virtual environment and install the required Python packages. Here I am using FastAPI, which is a Python framework for building APIs. Now create a file called app.py and add this code block. I will share this code and the GitHub repo link in the description box so that you can check and you can use this code. The ask endpoint allows a client to send a question along with the selected tag. When a request arrives, the function first builds file paths for file's vector index and its related document metadata based on provided tag. If the files are found, the system loads the vector database and stored document and retrieves the most relevant context related to the user's question. Finally, API returns a JSON response containing the original question. There is also a file called ragengine.py. This code implements the backend logic of the retrieval-augmented generation. First, it loads required libraries and defines configuration values such as the embedding model. Load vector store function reads the file's vector index and its corresponding document metadata, which together represent previously embedded document. When a user asks a question, retrieve context converts the query into an embedding and performs a similarity search in files to fetch the most relevant document chunks. The generate answer function then builds a prompt containing this retrieve context and sends it to the local Olama model to generate response. So that is the overview of this code. You can check and make changes that you want. Currently there is no authentication added in this code. You can add if you want. Performance and latency depends on your computer hardware. So if you are deploying in your server, you have to make sure that you are running enough infrastructure. Benefit of this RAG is you don't need to pay for the external APIs. You can manage your model. I had shared the GitHub link in the description box so that you can check and make changes that you want. So that's all about today's video. Thank you for watching and see you in the next video. Bye.